Hello and welcome to the show. It's me, JP, and we are here for JP's product pick of the week. And I want to thank you for stopping by. We have our chats over in YouTube, and hello to Dave Odessa, Johnny Bergdahl, Quinman16, Tackle the World. Thanks for stopping by over there. If you're somewhere else and you're wondering where is that chat, it is probably over here in the Discord. You can go to adafruit.it/Discord and look for our live broadcast chat channel right over there. That's where the chats happen during the shows. So this is a show on which I share with you a product pick, and if it's something that interests you, you can get a big, humongous discount right on the product page without needing a coupon code. We just slash the price, super, super deep discount. Behind the scenes here, I'm going to double check that that has happened, and indeed, wow, what a price this is. Can't wait to share it with you. That's the URL right there. If you want to go to this product, go to the page. This show is being broadcast inside of the product page itself, so you can be right there, all in one little self-contained, neat place where we try to convince you that this thing is something that you need, that this is the life-changing product you've been waiting on, or not. But if it's something you want, then hey, good time to get it. Before I go any further and tell you more about it, I'm going to let Lady Ada jump back a little bit in time and give us her take on this in the new products section. So take it away, Lady Ada.
The Crickit hats. This is the fourth iteration of the Crickit line, which is basically a helper board that does all the robotics hard stuff for you. So you can just stick to writing your Python code to do whatever you want your robot to do. So this Crickit, unlike the previous ones, which were like Microbit or Circuit Playground Express or feather-shaped, this one is Raspberry Pi hat-shaped. So let's go to the overhead. I can show this demo.
And if anyone who uses Raspberry Pi and tried to do robotics, it's always a challenge, and that's just the way it is because the Raspberry Pi is still somewhat new, and getting things to move and all the hardware and all the drivers, it's not easy. It's Linuxy, and so we think we fixed it. We think we have everything you need now to do robotics with a Raspberry Pi, and also works with CircuitPython. So if you use CircuitPython anywhere, this will be very familiar.
Or Python 3, same thing. The drivers are the same across the board. So the Crickit hat is just like a hat. It plugs in right on top, and it gives you all of the things that that a Raspberry Pi doesn't do well. So, I'll turn it off in a second, but you can see it's rotating a DC motor. This is a standard brushless motor. It's got servo control. And I'm going to turn it off just so it's not making noise. It's got, turn it upside down so it's more readable. So it's got 4 servo connections. So you can connect 4 hobby servos, the ones that take a pulse input, and it does all the timing for you on chip. So you get 4 servos, 8 analog inputs, or like digital outputs. So if you need analog inputs or PWMs or whatever, you can get them from this port. You get a 3-volt power, ground, and a signal. There's a speaker connection. On other Crickits, this is just connected to like the analog output of the circuit.
Not sure what happened there. Is this still, this is still broadcasting, but that video stopped. Let me see if I can continue that.
Crickit hats. This is the fourth iteration of the Crickit line, which is basically a helper board. The Crickit hats. This is the fourth iteration of the Crickit hats. This is the fourth iteration. Nope,
we don't get to watch that. I'm so sorry. It still exists. I promise you. If you go to the product page, I think we have that video from the new section. There's actually 2 of those. But that's okay. I'll tell you more about it myself. So first of all, let me get this over here and say that right there is my product pick of the week this week. It is the Crickit hat for Raspberry Pi. So this is a standard hat format, so it'll plug into any Raspberry Pi that uses the 2x20 header format. And this is how you're going to add robotics to your Raspberry Pi projects. So driving motors, driving solenoids, driving relays, driving steppers. If you need inputs, particularly analog inputs, which you don't really have on the Raspberry Pi, we've got 8 of them on here. We have a dedicated NeoPixel driver on here. They all have these handy screw terminals to plug in your things that you're using with this. What else? We have a set of 4 capacitive touch pads right here. You can use those as is or plug alligator clips and off to other sorts of aluminum foil or other things you want to use as touch sensors. This will also allow you to run through some of the ribbon cables on some Pi models for things like display and camera. You can fit those through some of the little notches in there. And what I wanted to do is show you a demo of this running on a Raspberry Pi here. I've got a Raspberry Pi 5 here. This is actually the first project I've used it on. So right here, this is a Raspberry Pi 5. You can see I have the Crickit right there, plopped right on top. And then I have power running to the Crickit. That's a dedicated power supply for motors and things. You usually don't want to mix your logic power supply and your motor power supply. So that's running the Crickit. This is a USB-C running the Raspberry Pi 5. Pi 5 has a pretty high current draw. I think it needs 3 amps, so best to keep these separate. You can power your Pi from the Crickit, but I would recommend not doing that. And then I happen to be running this one with a HDMI display, mouse and keyboard on it right now, so I've got some extra things plugged in there. You can, of course, run it autonomous, headless mode. You can run it over SSH from another computer, but I've got it all kind of set up as an all-in-one here. And then you can see what I've got plugged into my Crickit are a few little things. There's a DC motor here. There is a hobby servo here. We could have up to 4 hobby servos plugged in. And then I have one of these 8 signal input outputs as a analog input that I'm using for a potentiometer, this little potentiometer breakout. So what I'll do is I'll just run a Python program on here. So the way I have this configured, this is the Raspberry Pi. It is running Python 3. We have the Blinka libraries installed, and what that means is we can use CircuitPython libraries. All those great CircuitPython commands and libraries that you know and love from the microcontrollers, you can use those on the Pi with Blinka. So if I run that, we've now got control of that servo and the motor speed, forward and backwards. We can stop it right there. The motor's whining a little bit, but get it to where it stops right there. So this is all digital, or rather, yeah, digital signals to the servo. We have motor control signals running to the DC motor. We're reading analog input here. All stuff that's kind of tricky to do on the Raspberry Pi by itself, but you plop this on and you've got tons and tons of opportunities to add robotics types of peripherals to your Raspberry Pi. So if we take a look here, what I'll do is exit out of that program. I'll just reset the board here. There is, by the way, an on-off switch on the Crickit. There's also a little reset button there. And as Lamore mentioned, we also have a USB serial converter here, so you can monitor what's going on this over serial using USB cable if you want to. And I'll show you the program I have running here. This is just in this sort of simple nano text editor on the Pi 5. All I need to do to use this, import Adafruit Crickit. That library will give us all the other stuff we want. So to run servos, I've got these types of controls here. Crickit.servo1 angle, just tell it what angle to go to. Motor 1 throttle, give it negative 1.0 to positive 1.0 in float values. And then that's some previous demos. What I'm actually running here is I've got the potentiometer being read with SS, that's Seesaw chip, so this is all running with a Seesaw chip. SS.analog read pot 1. We could go all the way through 8 of those if we needed to. And then I'm taking those values and turning them into something useful for both setting 0 to 180-degree angles on the servo, or that negative 1 to positive 1 on the DC motor. And then to drive those, again, you can see here, Crickit servo 1 angle and motor 1 throttle value. So I'll exit out of that, and if I run that again, you'll see that's all that's being called, just using Python 3, and now I have this added control. We could be doing NeoPixels with these. We've got a amplifier on here is a 3-watt amp, so you can plug in a speaker into the screw terminals there and have lots of sound going along with your project. So really neat to add things. It could be props, it could be animatronics, it could be robotics. Those are all really interesting things to do on a Raspberry Pi, especially if you want things like computer vision using a camera or to be able to use some more sophisticated networking to control things with Wi-Fi. Those are all possibilities on the Raspberry Pi, but again, difficult to do on its own. It just has digital input-output pins on it by default. This is a great board to add to it to give you a huge extension of possible input and output that you can use. So let me see, let me check out over in the chat what's going on over on YouTube chat. Questions. Any battery questions? Oh no, that's just about shipping. Okay, some questions there about shipping. So what else? No questions, good. Okay, so let's take a look at the product page here. I'm gonna jump over here so you can see this is product ID 3957. And it is normally $35 for the Crickit hat. Right now, $17.48. I think we still have these in stock. We stash a few right at the beginning of the show so they don't sell out instantly. Maximum of 10 per customer and no resellers, but you can throw these in a cart. You don't need a coupon code or anything like that. You can just get them and they'll run at that price until the end of the show. After the show, it goes back up to the regular price. The add-ons that you can click here, I would recommend at least a 4-amp power supply or maybe even a 10-amp power supply, 5-volt. That's what's providing power to the Crickit and then everything that's running on the Crickit. If you take a look here, we've got a list of some of the features on here. So 4 analog or digital servos with precision 16-bit timers. And if you look, go back to the down shooter here. Oh, actually, I'll show you right here. If you look right here, we have these are sort of the standard header pins, 3 pins for signal, power, ground that you plug a servo into. So most hobby servos that you'll get, including all the ones that we sell in the store, will have that type of DuPont header with the signal, power, ground in that order. So you can plug those right in there, up to 4 of those on there. We've also got a 2 bidirectional brush DC motor control, 1 amp current limit on each, and those are 8-bit PWM'd. There are 4 high current Darlington 1/2 of an amp drive outputs, and those have the kickback diodes on them, so you won't get an onrush of reverse current, so you can use those to drive things like solenoids and relays. It can also drive really powerful LEDs with those, or unipolar steppers. So you can do unipolar stepper motors on that. You can do bipolar stepper motors using the 2 motor drive outputs. There are the 4 capacitive touch sensors on it, the 8 signal pins that I mentioned, and those can be buttons. You could use simple buttons on those. It doesn't have to be analog inputs. Those could be simple digital inputs, and they can be digital outputs. And then we have the NeoPixel driver with 5-volt logic and power, so you can drive big strips of NeoPixels on here. Again, something you can't really do on a Raspberry Pi very easily on its own. It's difficult to get that precise timing, but with the Seesaw chip on here, no problem running hundreds of NeoPixels with correct timing. Then we have the Class D amplifier, 4 to 8 ohm speakers, 3-watt maximum. You can drive a pretty big, loud thing on there. And then the USB to serial converter is on there. If you take a look a little lower down here, there's a link to the primary learn guide, and this will take you through all of the different setup that you need to do. So it's a setup of Blinka on your Raspberry Pi, so this will take you through all of that and installing the proper libraries. And then once you've gotten through that initial installation, this will tell you how to drive servos with some sample circuit diagrams as well as test code. And you can even do that right from the command line, so you can type in Python commands directly to the board and get it to show up. So really good for iteration that way. So that is it. There's a nice look at it a little closer up with some of the motors plugged in, and here is the front and back of the board. It also, by the way, comes with a handy 2x40 through header. So soldered directly on it is this little surface mount one, and I'm actually using that directly on the Pi 5. The Pi 5 is pretty low profile, so you can plop this right on. Some Raspberry Pis will have parts that are a little higher, and then you can use this extension to get yourself a little extra height, and it'll float off the top there. There are also mounting holes on there that line up with the Pi mounting holes so that you can secure that with some screws, maybe some nylon standoffs, that sort of thing. What else? Anything I'm missing? I think that should cover it. So let me know if you have any other questions over in the chats. John Richardson says, what environment can you develop for the Pi in? So this is not acting like a separate microcontroller that you compile for. So it's not like other of our boards. It instead is all over I2C, and the Crickit library takes care of it in Python. So there may be other languages you can use, but in Python on the Raspberry Pi, I'm using Python 3. I'm simply sending commands right to there. In fact, let me see if I can illustrate that a little better. Let me jump back to this view. So I have a separate keyboard and mouse over here plugged into this one. So if you look at this code right here, importing Adafruit Crickit, import Crickit, and then setting up, let's say, the motor as motor 1, as Crickit DC motor 1, we could then immediately, just in Python, those would all be Python 3 commands, type in this motor 1 throttle equals 1, and the motor would just start running. So those would be 3 commands that you could do right from the command line. This, yeah, so it's not firmware, so to speak. There's firmware running on the Crickit, and you kind of update that over the USB to get it up to the latest. So it's using the Seesaw firmware, which is a way that we're using. I think might be a SAMD21 on there to interpret all this stuff over I2C. But the Blinka and Circuit, the Blinka allows you to use Python on the Pi to run all of the CircuitPython commands. And the CircuitPython Crickit library installation kind of takes care of all of it. So we just get to use these high-level commands, if that answers your question. And this is I'm running the latest Raspberry Pi Bookworm on here. So pretty much any Linux installation on the Pi, you'd be able to do this from. Hope that answers your questions. Let me know if you have any others. I think that's it, though. I think that'll cover it. So let's wrap this up. Don't forget, you can head right here to product ID 3957 to get these right now at this discount. And one more question I got from Thin Man. Could you program the Seesaw on the Crickit? Yeah, so you could potentially plug a USB cable from the Pi to the Crickit and update the firmware on there. You may need to go through a programmer like the UPDI programmer. I'm not sure about that, but that is a programmable chip. It's a Seesaw chip, I think, just a SAMD21 if I'm not mistaken, like all of our other Crickits. So yeah, you can program that separately, but if you don't want to go that low level, you can just use the Crickit commands, which run over I2C from, just uses 2 pins from the Raspberry Pi to the Crickit, and then that chip on there, the Seesaw chip, takes care of all of the rest of it. So it's very easy, very lightweight. AERGR says the powering page mentions the Crickit power supply will also power the Pi itself. Yeah, and I think on a less power-hungry Pi, you'd be okay. Let's test it. Why not? So this is USB-C that is driving my Pi right now. Make sure my Crickit is on. My Crickit has a 5-volt, 10-amp supply. I'm not telling it to do anything right now, so I'm guessing a decent chance the Pi will stay on. Let's see. Yep. Okay, so the Pi is being powered. This was the USB-C that was powering the Pi. So my Pi is being powered from the Crickit, which is the same as any of our Crickit boards, but if I drive the motor and stall it a little bit, there's a chance that the current will draw more than the Pi is happy with dropping down to. This Raspberry Pi 5 wants 3 amps, and it gets complainy after that. Let's just see. We'll test fate right here. I'll drive. Oh, the monitor just shut off. I think it's already unhappy. Yeah, so don't do that. Maybe on a lighter weight Pi. Yeah, that was a good demo of it. I think it browned out a little bit. Yeah, in fact, my Pi power is off now, so don't do that. Maybe we'll update that page. We should update that page to say it'll vary depending on the Pi you're using, but 5 is pretty hungry, so yeah, there's your answer for you right there. Let's see, I don't know if there's any other questions. I think, oh, Marie Meyer says they ordered 2 for a Droid build. Very cool. We'd love to see that. Droid build sounds great. Yeah, this could be a good one for a little droid. Quinman, is there a way to install Adafruit libraries on the Pi and Blinka? If you're asking about something like CircUp, I don't know. That's a good question. I'd love to know if anyone knows if there's like a easy front end for installing libraries. I believe if you check the, and I just did this the other day, so I should remember, but if you check the Learn guide on Python installation, this is the installing Blinka. It's a few commands from the terminal. And let me check. So, okay, it's pip. Yeah, so pip3 install Adafruit, CircuitPython, Crickit. So that's your answer. If you use pip3, any of the Adafruit libraries for Blinka should be available right there. And then, oops, that's more than you want to know right there. And then those are now available. You'll use a virtual environment. That's all listed in the this Blinka page here. So I just followed these like a day or 2 ago to get this one set up, and it all worked fairly smooth, pretty smoothly, I'd say. All right, I think we'll end it there. So that is my product pick of the week this week. It is the Crickit hat for Raspberry Pi. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week. I'll see you next time. Bye-bye.